Hello students, hope you are doing well. In this video, we are going to look at a few concepts from the chapter Waves and Sound. So here in this chapter, we will be discussing about both waves and sound waves. The topics that we are going to look at are what is a wave, we will try to define what is a wave, we will try to understand what is a wave. Then we will look into the various types of waves, that is what are transverse waves and what are longitudinal waves. And then we will try to write a general equation of a progressive wave. A progressive wave is a wave which travels or carries energy from one point to other point. So let's first understand what is a wave. A wave is an organized disturbance which travels in space at a well-defined speed. So in general terms, I can say it is a disturbance traveling from one point to other point, or it is a pure energy which is traveling in the form of disturbance from one point to other point. Now as an example, you can see that we are showing a speaker which is producing a disturbance. The disturbance is going spreading throughout in all the direction in the form of a speaker. Now here you will see that there is no mass that is being transferred from one point to other point. The air molecules are vibrating and they are carrying energy from the speaker to various points in the medium. Now the wave that you can see below here is an electromagnetic wave. So here we see that energy in the form of electric and magnetic fields is carried from one point to other points. So what is a wave? I can say wave is transfer of energy without transfer of mass. That is one way of looking at it. Other way of looking at it is I can say a wave is a disturbance which is traveling from one point to other point in space. So of course, depending on whether it is traveling in a medium or if it doesn't require a medium, we can classify it into mechanical waves and non-mechanical waves. Mechanical waves are waves which require a medium to propagate from one point to other point, and non-mechanical waves are waves which do not require a medium to propagate from one point to other point. So here the sound that is traveling from one point to other point, this is mechanical wave because it requires a medium to propagate. Now this is light or electromagnetic wave, this is non-mechanical wave. So in this chapter we'll confine ourselves to only mechanical waves. Non-mechanical waves we'll be looking into in the next chapter. So electromagnetic waves or non-mechanical waves are waves it's a wave which is a traveling fluctuation in the electric and magnetic field. Now it does not require a medium, that's why we call it as a non-mechanical wave, and its speed is equal to speed of light in that particular medium. Now the various parts of the spectrum are gamma rays, X-rays, ultraviolet, visible, infrared, microwave and radio waves. Those are the various parts of spectrum. So any of this part is a part of electromagnetic radiation. Mechanical waves. So these are the waves about which we are going to study mostly in this topic. Mechanical waves are waves which require a medium to propagate or which require a medium to travel from one point to other point. Now what does propagation of wave means? Propagation of wave means transfer of energy from one point to other point. Now these mechanical waves are further classified into two categories. They are longitudinal waves and transverse waves. In longitudinal waves, the medium particles oscillate parallel to the direction of let's say propagation of energy, or that's what is the direction of motion of wave. So how does the energy being transferred? Like here you can see this is an example of longitudinal wave. I compress the spring. The compression travels from one point to other point, and the oscillation is also in this direction. So this is longitudinal wave. Now here also you can see that the disturbance, the points where the density of particles is more, that is the disturbance. Now disturbance is traveling, and the particle, you can see that the red particle is oscillating in this direction. So the wave travels like this, energy is being transferred like this, and the particle is also oscillating like this. So this is longitudinal waves. Or in simple words, what I can do is, if I have medium particles like this, I push this particle, I disturb this particle, this goes, hits and comes back, then this goes, hits and comes back, this goes, hits and comes back, and so on. What is happening is energy is being transferred from one point to other point. So these waves are called longitudinal waves. So now let's come to transverse waves. Now transverse waves, what is happening is the medium particles, something like this, they are oscillating like this and the energy is being transferred like this. So what is happening? The medium particles oscillate in one direction and the transfer of energy takes place in a direction perpendicular to the motion of the particle. Now here you can see that the blue waves, this is the direction of transfer of energy and this is the direction of oscillation of particle. So that is why this is a transverse wave. Now one important thing is, if this particle has to transfer energy to this, then the only way in which it can disturb this is by being in contact with this. Only then what will happen is this wave will disturb this. So what is necessary is, whenever we have a transverse mechanical wave, the particle should be in contact with each other. So that's why transverse mechanical wave can only propagate in solids or liquid surfaces. Now let's try to write equation of a progressive waves. So some of the general terms which you already are familiar with is a crest, that is maximum displacement from mean position in positive direction, trough, maximum displacement from mean position in negative direction, wavelength, separation between two medium particles of a wave which are oscillating in same phase, or I can say in general it is the separation between two consecutive crests or two consecutive troughs. So any let's say any function of linear combination of position and time can represent a traveling wave. So any function which is a linear combination of position and time can represent a traveling wave. So this is the condition. Now the coefficient of x in this case, coefficient of x a which is represented by k is called wave number. So a which is represented by k, it is called wave number. B which is given by omega, it is called wave frequency, right? So these are the, so in that way I can write y should be a function of I'll say kx plus or minus omega t. Now a few more things that we can infer from this is, if y equal to f of kx plus or minus plus omega t, here this x represents the direction of motion of energy, here this y represents the direction of vibrations of particle. So this represents a wave traveling along negative x direction. So this is traveling along negative x. So because there is a positive sign here. Similarly, y equal to f of kx minus omega t. If there is a negative sign between these two terms, this represents a wave which is traveling along positive x. So I can say here medium particles are oscillating in which direction? The medium particles are oscillating along y axis and the energy is being traveled along x axis. Because they are traveling perpendicular to each other, these waves are representing transverse waves which are traveling along x axis. Now for example, using this, similarly I can write z equal to something like f of, let's say, kz minus omega t. This represents a wave whose medium particles are oscillating along z and the energy is also moving along x axis, sorry, z axis. So this is a longitudinal wave. So in this way, by looking at the equation, I can say whether the wave is longitudinal or transverse. I can say what is the direction in which the wave is traveling. So this is a general equation of a progressive wave. Now let's try to get in. A harmonic wave is represented by, I am taking a transverse harmonic wave, but I can similarly represent longitudinal harmonic wave also, a sine of kx plus or minus omega t, right? Now I can take sine or cos because there is only a difference of phase, nothing more than that. And here a is the amplitude. Amplitude is maximum displacement from the mean position. Now there are various ways in which I can write this expression. This can be written as y equal to a sine. I can take out omega outside, I will be left with k by omega into x plus or minus t. Now this can be written as y equal to a sine, omega is taken out, I will be left with x by omega by k, x by omega by k plus or minus t. Now x by omega by k is x by v. So this can be written as y equal to a sine omega into x by v plus or minus t, any of these forms. So I can convert them in from one form to other form using the expressions v equal to omega by k, or omega equal to 2 pi by t, or k equal to 2 pi by lambda. Any of this expression would give us the wave. So from this, what we can infer is there are a lot of information that we can know from the equation of a wave. From the equation of a wave, we can find out what kind of a wave it is. Is it a transverse wave? Is it a longitudinal wave? We can find out the direction of vibrations of the particles, direction of motion of the wave. Motion of the wave is the direction in which the energy is transferred by the wave. We can also find out whether the wave is traveling along positive direction or negative direction, and we can find out what is the amplitude of the wave. If I know amplitude, I can find the intensity of the wave, and we can find what is the velocity of the wave. So these are all the information that we can get from the equation of a progressive wave. So let's have a quick recap of what all things we have done. We have tried to define a wave. A wave is a disturbance which travels in space without transfer of mass. Then we have seen that wave is classified into two categories. One is mechanical and non-mechanical, and we are confining ourselves to mechanical waves in this topic. After that, what we have seen is mechanical waves are further classified into two categories: longitudinal and transverse waves. Longitudinal waves are waves which travel in which the medium particles vibrate along the direction of motion of wave, and transverse waves are waves in which medium particles oscillate perpendicular to the direction of transfer of energy or motion of wave. And then finally, we saw how do we write equation of a progressive wave and various forms in which the equation can be represented. Hope you could follow all these things. Thank you very much for watching this video, and keep watching all other concept videos and the questions and applications of these concepts and various questions and the video solutions of this, which are provided by Get My Class. Thank you very much once again for visiting Get My Class.